different questions that IB likes to ask for quadratics. So we've got this quadratic function here. They've given us the graph. They give us some information about it with x-intercept and a maximum point with the x-coordinate. They give us the function, and they ask us to start solving, right? Find the value of b. Well, I know that this is in the form ax squared plus bx plus c equal to 0. And I know that I also have another equation that I can use to find b, right? And it's negative b, right? Negative b over 2a. And that's the vertex, right? That equals my vertex, or my axis of symmetry, right? Rather, this is the formula for axis of symmetry. So we're going to just plug these in, because I don't know what my b is. I'm looking for it, but I know what the x value is. They told me my maximum point, right, which is going to be a point on the axis of symmetry, has the x-coordinate value of 3. So I know whatever this is equal to 3. So I end up with negative b over 2. Well, what's my a value? They've given me the equation here, and I know the a is whatever is in front of the x squared. So it's negative 1. So this is all equal to 3. So, I mean, the negatives are just going to cancel each other out there, right? Negative divided by negative is a positive. And I'll end up with 2b over 2 is equal to 3, right? And then I'm going to cross multiply to get b by itself, and I'll be left with b is equal to 6. So for this value down here, b is equal to 6. The next thing they ask you to find is c. And this is actually going to be helpful in our next problem as well, to see how we're doing stuff like this. So we're looking for the c value now, but we already have a b value. So we can just start plugging stuff in here, right? They've also given us that one of the x-intercepts is 5, 0. And that's helpful because it gives us an x value where we get a y value out. So for instance, if I were to plug in here, right, f of 5, I would get out 0. So let's just plug that in and do out the algebra, right? So if I plug in 5, I'm getting out 0. So anywhere I see an x, I'm going to put in 5. And I already know what my b value is. I've solved for it. It's 6. And again, there's an x, so I'm putting in 5 plus c, and now c is the only variable I've got left. When you multiply this, you get 30. When you multiply this, you get negative 25. 30 minus 25 gives you 5 plus c is equal to 0. And when you solve, you get c is equal to negative 5 here. All right, so now they're asking us to find the range. Well, they've given you the domain. They're saying, okay, the domain is in between these two lines. It's between 0 and 6 on the x-axis, right? 0 and 6 on the x-axis. What we already know is that the maximum point up here has an x value of 3. And we are looking for whatever that y value is, right? Well, again, we're going to do the same thing, the same idea that we found here. We're going to apply it to this question, right? I know if I plug 3 in, I've got to get something out. What am I getting out? I don't know, right? I'm getting f of x out or y value out. I'm not really sure what that number is just quite yet. So I'm just going to have to plug in to find it. So whenever I see an x now, I'm going to plug in a 3 because I'm concerned about what f of 3 is equal to. So I've got negative 3 squared plus, right, wherever I see a 3, I know my b is 6 from the previous problem, times 3. And I know that my c value is now negative 5. So when you do all this out, you end up getting f of 3, right, is actually equal to 4. Okay, f of 3 is actually equal to 4. So our point up here is 3, 4. Well, what about the bottom point? Well, the bottom point we know is negative 5. And the reason we know that is because c is negative 5. So in this equation, our c value is always the y-intercept, right? So I know that this point down here is 0, negative 5 because it's always the y-intercept. So my range is between negative 5 and 4. And you can write that as an inequality too if you want. I just chose to use my brackets. All right, so let's take a look at the next question. This one gives you like a function where you're looking at, okay, x goes on to f of x. If I plug something in for f of x, I'm getting these things out, right? So the only one they haven't given us is c. We take a look, okay, they've said some stuff about the mapping diagram. Use the mapping diagram to write down two equations in terms of a and b. All right, well, at first glance, it looks kind of difficult because you don't really look at stuff like this, or, it's kind of confusing maybe at first glance, but it's really not that bad because they're saying solve the equations to find the values of a and b. Well, I don't really know what a and b are just yet, but I know if I plug 1 in, I get out a -9. And if I plug 3 in, I get out a 119. So how can I use this to my advantage? Well, I see that over here, this is the equation. Ax squared plus b is going to be equal to my f of x. So I'm going to use that to my advantage, right? I know that a, right, x squared, my x I'm going to plug in here is 1 because I'm taking the x from over here. These are my x values, squared, plus b is equal to -9 because this is my f of x, right? And I know ax squared plus b is equal to f of x. So this is -9 here. Okay, and then the next one I'm going to do is the same thing, but this time it's going to be a times 3 squared plus b is equal to 119. And again, that's because I know these are my x values, these are my f of x values, and the function, the quadratic function itself, is ax squared plus b. So how is this helpful to me? Well, if you do this out, you get 1 squared is just 1, so we're left with a plus b is equal to -9. And if you do this one out, you get 3 squared is 9a plus b is equal to 119. And maybe you remember from Algebra 1, but you can actually, since these have the same variables, we can subtract them from each other, right? And we'll end up with one variable left in our equation because we have a 2 variable equations. We have 2 variables and 2 equations. We want 1 variable and 1 equation. So if I subtract these, I'm going to end up with 8a. The b's actually cancel out. And 119, right? 119 minus -9, which is really plus 9, gives me 128. So 8a is equal to 128. And then I'm going to divide by 8 from both sides, right? And I'll be left with a is equal to 16. So a is equal to 16. And then I'm going to plug back into one of these simpler equations. I'm going to plug back into this one because it's easier. So 16 times 1 plus b is equal to -9. 16 times 1 squared, right, which is just 16 plus b is equal to -9. And when I solve for b, I'm going to subtract 16 from both sides, and I'll be left with b is equal to -25. So a little bit confusing, but once you set it up, the math is pretty simple. But now we have our a and b values, right? And it's asking us to find the value of c. Well, now I know what I'm looking for. What do I have to plug in here to get out 117? And what you have to plug in, right, we're going to have to solve for using the new values we just found, these new values a and these new values b. So here again, I'm using this equation. A I now know is 16. I don't know what my c value is, so I'm just going to say that it's c, right? C squared. Plus, I know what my b value is. It's -25, right? And then I know what it's going to be equal to. It's 171. So once you solve for this, you'll see that c is equal to 3.5. So maybe that was a little tricky to see because you had to plug in what you had just received as answer choices. Let's take a look at the last question that we're going to look at for today. The graph shows this. it intersects the y-axis at 0, 5 and has this vertex point, we want to write down the value of c. Okay, well, that's very easy because we've looked at this before and we know what our c value is when it's ax squared plus bx plus c. Our c value is always our y-intercept. Well, they told us what our y-intercept is, right? They said it was 0, 5. So our c value must be equal to 5. Our c value must be equal to 5. Find the value of b. B is right, this second term in our equation. What's the value of b? Well, again, we can use that axis of symmetry formula, right? So negative b over 2a is equal to x. We're going to use this to find the axis of symmetry, but really we're going to use it to find the value of b because we have some of these terms already, right? We don't know what b is. We're going to find that. We do know that our point here was 2, 9, so we know our x value is equal to 2, and we know that this is our equation, and our a value is equal to -1. So we get 2 times -1. And again, the negatives will end up crossing each other out, right? Because negative times a negative is a positive. So we get b over 2 is equal to 2. And then we're going to multiply, cross multiply to get b by itself, and b will be equal to 4. All right, so our b value is equal to 4. Now we've got to find our x-intercepts of the graph, right? So how are we finding our x-intercepts of the graph? Well, we can just factor now because we have all the numbers for this equation, right? We have y equals, right, negative x squared. I'm just going to write this in the right form, or standard form, negative x squared, plus I know what b is. It's 4. It's 4 because I solved it over here, right? And then I know what my c value is. It's 5 plus 5. So now I just have to find factors, right, that multiply to 5 and add to 4. But there's one thing here. I'm going to take a negative out just so that it's easier for me to factor. So I'm going to take a negative out here because I want to factor a positive trinomial. So I'm taking a negative out, and now my 4 becomes negative, and my 5 also becomes negative. And you'll see that this is easier for me to factor because now I'm finding something that multiplies to a -5 and adds to a -4. And that's easy because it's just going to be x minus 5 and x minus 1. All right, and now we see if I split these and I solve for x, I get x is equal to 5. I'm sorry, plus 1 here, and x is equal to -1 on this side. So the x-intercepts of the graph, x is equal to, well, you could just write 5 and -1 if you wanted to, but don't put parentheses around it because then it'll be misconstrued as a point. And they've asked you to write the equation in this form, and we've really already done that with this line here, but we can write it again down here if we want. Negative, right? I've written x minus 5, x plus 1. And that's the form they wanted in. All right. I know this was a long video. If you stayed on for the long haul, thanks. Please like and subscribe. All right.